There are lots of people who believe that mathematics is but just a set of formulas to remember. But to me, there's so much beauty in mathematics. There's so much pattern. And the thing is, mathematics has so much use in our daily life. We're using mathematics when we're paying for something. We are looking at how the economy grows, the growth rate. We are looking at how we exchange money, the exchange rate, and how fast a disease is spreading, the information that's communicated to us. All these involve numbers. We have all learned Pythagoras' theorem in our classroom. Have you ever thought about using it outside of the classroom? How about the abstract algebra? They all taught us how to think logically. Mathematics train us to be better thinkers. I think Singapore Maths prepare our students to go beyond just knowing how to apply the formula to solve a problem, to do the mathematics, but to understand the concept behind the mathematics that they are using, to see the connection between the mathematics in the classroom as well as the mathematics that's needed to survive in real life. And we do this by making it easier and accessible to the kids, to build their confidence, to gain their interest, to get them to appreciate the beauty of mathematics. To do this, we need to understand the cognitive development of our children at that age. According to the Swiss developmental psychologist Piaget, children at this age are concrete learners. As such, it is important that we use concrete materials to allow our students to gain access to the abstract mathematics and to make sense of the mathematics. Materials like this help students to better appreciate the abstractness of mathematics, but at the same time, to know how mathematics is linked to the real world. Materials like this are called manipulatives, and they could help students to make better sense of the abstract mathematics. I think a lot of students think that mathematics is just about remembering the formula, applying the formula. As such, they find it very, very difficult because it's all about memory work. But in mathematics, there's a need for people to make sense of the mathematics in order for them to be able to apply mathematics effectively and efficiently. They need to think about their own thinking. They need to understand that when are they oversimplify the whole mathematics they're learning, and when they actually overcomplicate the whole issue of mathematics that they are doing. And this is important because we want our students to learn the thinking behind the doing of the mathematics so that they can make better sense of the abstract mathematics in relation to the actual life of mathematics that they're living in. And this is where we want to encourage our students to develop their thinking, mathematical thinking, logical thinking, to be creative as well as critical thinking. Not to mention, it is important that we encourage our students to look at their own thinking, to evaluate their thinking, and to control their thinking. And this is what we call metacognition, a skill which we always call a 21st century life skill, a skill that will equip our students with the world in front of them, with the future world where nothing is constant but change. Remember, as I said earlier on, the students are concrete learners at this particular age. So it is important for them to have access to concrete materials to make sense of the abstract mathematics. We can introduce activity-based learning experiences in our classroom so that the students have access to the concrete material to make sense of the abstract mathematics. An example will be the counting bears. These are concrete materials. Not only that, these are teddy bears. They look like teddy bears. The teddy bears that our students love when they're kids. They can make sense. They can relate to the teddy bears. But these teddy bears are different. They are what we call teaching resources because they're specially made with special attributes. Look at these bears. We've got different colors. We've got different sizes. This will allow the teacher to provide feedback as the students use these counting bears to construct their knowledge in mathematics by giving them feedback in terms of their thinking so that they are better in knowing what they're thinking, help them to evaluate their thinking, help them to control their thinking so that eventually they develop the correct and right mathematical thinking that helps them to learn mathematics confidently and appreciate the beauty of mathematics. Let's try to look at an example here. I have some counting bears here. Look at how many of the yellow counting bears that I have. 6 of them. I also have 4 orange counting bears. How many counting bears do I have altogether? There's 6 yellow, 7, 8, 9, 10. And this is where you find that the student will now be able to count concretely to add and make sense of what we mean by 6 and 4 makes 10, or 6 plus 4 makes 10. Now, of course, we can also use the same set of manipulatives to teach subtraction. Look at the orange counting bears. There are 4 of them. Look at the yellow counting bears. There are 6 of them. Did you notice how clear it is now in a concrete manner that there are 2 more yellow counting bears than orange counting bears? And this is where we talk about 6 minus 4 equals 2, as there are 2 more yellow counting bears than orange counting bears. This is not it. We can also use it to teach how to count large numbers. Look at this set of bears here. How many there are? Are we going to count one by one? But you see, we actually can see there are 3 red bears. How many colored bears do we have here? 1, 2, 3, 4, 5, 6, 7. 7 bears here. And 7 and 3 makes 10. And that makes the counting so much easier because I don't have to count everything. It doesn't stop there. It doesn't stop there. Let's look at this set of counting bears. How many there are? Are we going to count 1, 2, 3? Oh, it's going to take a long time. But let's look. There are 4 colors of counting bears. And look at each set. There are 3 counting bears. In other words, we have got 4 groups of 3. And this makes it easier because they are equal groups and you can add 3 plus 3 plus 3 plus 3, which is 12. Or we can talk about 4 groups of 3, which is the same as introducing the operation multiplication. 4 times 3 equals 12. And get students to appreciate why they're learning more mathematics, why they are learning more operation, because there's so much efficiency as we move on to learn more mathematics. It makes our counting, our sorting, our doing of mathematics more and more efficiency. In other words, we are thinking more and more like mathematician, thinking mathematically. In activity-based learning, you find that the students learn by being hands-on and immersive. And this helps them to make better sense of the mathematics that they are learning. Yes, in fact, there are many manipulatives that our students can actually use to learn mathematics. There are manipulatives for students to learn about time. There are manipulatives that help students to learn about math. There are manipulatives that help students to learn about length. Now, what if we do not have the manipulatives? We can use other items too, especially household items, which students are very familiar with. And this is where the parents could also play a role to help students connect the abstract mathematics with real-life experiences. Take, for example, the Lego blocks that our students are all very familiar with, and many households will probably have them as toys for our students. They can also be used as a form of manipulatives to help our students to connect between the abstract mathematics and the real-life concrete experiences. Some manipulatives actually can use to teach more than one aspect of mathematics. Let's take a look at the tangram puzzle, something that our students may be very familiar with as a game that they play with. There are 7 pieces to this tangram puzzle. Let's take a look at the green set that I've used. I used 4 of the 7 pieces to form this. How does it look like? Doesn't it look like a little house? Yes. Our kids will say, I have made a house using 4 pieces of tangram puzzles. Look at the blue one. What does it look like? It looks like a tree, a Christmas tree. Again, the child uses 4 pieces to make, but make a different object, a Christmas tree. This is where we can encourage our students to be more creative, promoting creative thinking in our mathematics classroom. Not only that, let's take a look at this triangle. I have also some smaller triangles. Let's take a look at what I'm going to do. I'm going to put these two smaller triangles together and put it on top of that. You notice that the two smaller triangles is the same space as this triangle. Let's take a look at this square. Let me put these two smaller triangles together again. Notice how similar they are. I'm going to put it on top. Look. Again, the square occupies the same space as the two small triangles. Doesn't stop there. Look at this parallelogram. I can now put these two small triangles, and you notice that I can form the same parallelogram. In other words, while these three shapes are different, they have the same area. So we actually can use a tangram to teach about creative thinking in our classroom, as well as area in our classroom. Do we stop there? Oh no. Remember what I said earlier on. I can use these two smaller triangles to form this bigger triangle. In other words, each of these small triangles is one out of two equal parts of this bigger triangle, or each of these is half of the bigger triangle. We can actually teach fractions too, making sense of fraction using the tangram puzzle. Talking about fraction, let's look at the Lego pieces that we're all very familiar to. Look at this piece. I have a blue piece below, and I've got two yellow pieces on top. You notice that I can use two of the yellow pieces to form the blue piece. In other words, each of the yellow piece is one out of two equal parts of the blue piece, or half. Again, just like the way I have talked about fraction using the tangram puzzle. Does it stop at half? No. We can use bigger pieces too. Look at this. We have a white piece, and we have got some red pieces. We have got actually three red pieces that makes up the white piece. In other words, each of these red piece is actually one out of three equal parts of the white piece, or we have that this is 1/3 of the white piece. So we can actually learn about fractions also using the Lego blocks. Manipulatives are not just a classroom resource. You can also find manipulatives in the household items that we use daily. And these are the visual aids that we can engage students in learning mathematics both in the classroom and at home in a hands-on, fun, and immersive manner so that they can better appreciate the beauty and the nature of mathematics.